So not too terrible. Not terrible, but different. So here, I've seen this shown up a lot on provincial exams. This actual question, less about transformations and more like this, where you're given an actual function or an equation of something, and it says graph the square root of it. So here's our original function. What kind of graph is that going to result in? It's going to be a linear. It's going to be a straight line, right? Because there's just a single x. So we know that that graph is linear. And the reason why those things are important is because if you know what these things are, you know what to expect. So I'm trying to build in like little habits for you guys to get into, to just do your best to remember little checkpoints to help you, like, does that make sense? Does that not make sense? So we're going to go ahead and graph that linear function, and we're going to go ahead and graph the root of that linear function. So if I rearrange this to how do you feel about that? I like seeing it like that better. That makes my brain happy. Y equals mx plus b. My grade 9s right now are learning that that's a positive but can be written as an add. It's like mind blown for those sort of things. I did show them someone's test today. I showed them their chapter 5 calculator portion. Somebody went through and circled like all the important stuff in it, and we're just starting word problems. So I used your guys' work as an example of like strategies to use when going through word problems. So kudos to you for teaching the youth. Because it makes more sense when it comes from you.
So when's the royalty payment coming then?
Well, I'll tell you, Steve, as soon as I get mine, you'll get yours. Okay? All right. Super easy for this one. Y-intercept is at +3. Slope is down 2 to the right 1, right? We can graph that pretty easy from the pattern. I am going to take a minute, though, to do a table of values. Okay?
Don't worry about the royalty payments. Our math focus.
All right. So I'm going to do a table of values here. -2, -1, 0, 1, 2. I'll throw a 3 in there just to be kind. All right. At -2, what is the graph at? 7. Good job. And at -1? 5. And at 0? 3. Do you guys notice the pattern? This is linear. So what are we going down by every time? -2, right? We're going down by 2. So this would be 1. That would be -1. And then -3, hopefully. Do you guys remember when that stuff was hard in grade 9? No?
This is giving me good memories.
Good memories. It's bringing back all the warm and fuzzies. Warm and fuzzies? All right, so let's graph that. I need some increments here. So, what do I want to go up by? I think I want to go up by every second one. This one up and go by. Anybody take a look at the website for the exams yet? No? Okay.
Where's the website for exams?
Oh my God. All right, I'm going to plot those points. Pretty straightforward. We know 0 and 3, -1 and 5. And then that -2 is going to go off my graph, so I'm not going to graph it. 1 and 1, 2 and -1, 3 and -3. And if I did that right, oops, dropping my ruler. If I did that right, they should all line up in a linear. The reason why I say linear is because sometimes we get math fatigue and we don't know, we don't quite remember. You make a small calculation error, but if you know your line's linear and you graph it and it's not linear, then you have to go back and do something different. All right, so did I need a table of values? Not to graph the linear, but yes, to graph the radical, graph the square root of the function. FYI, ladies and gentlemen, we are just going to be square rooting. We won't be cube rooting or quadruple rooting or anything like that. It'll just be square roots. Everybody have their linear graph down? Hopefully. All right. So really what we're doing here is we are graphing the square root of the y values. So we're going to put that table of values back, and we're going to square root y values only. So my x values stay the same. My x values stay the same, but my y values are going to be square rooted. So this would be the root of 7, which that's not helpful to me when graphing. So root of 7, so that's 2.6. And then it's going to be the root of 5. And I'm just going to put the root signs. You guys obviously know what I'm doing, but I just want to remind us that that's what we're trying to do here. Square root of 3. Sorry, my brain's not functioning as fast as it normally does. What's the square root of 1, everybody?
1.
Thank goodness. Don't need my calculator for that one. What's the square root of -1? Can't do it. There's no value here. It's an imaginary number. So I can't take the square root. I'm just writing no value. We know that our graph can't be below that x-axis because we can't square root those numbers. But we missed a point. We missed a point. What value did we miss? Yes. What 0? I think I know what you're talking about, but which one?
The y value of 0.
Yeah, the y value of 0. We're looking for our x-intercept because that's going to be the lowest point on the graph, right? We missed this point in our table of values because that's going to be the starting point of the radical graph because that's our first rootable number. Does that make sense? I'm not even sure if rootable is a word, but you get the idea. 0 is the very first number we can take the square root of. So really what we need in this table is we need where y is 0. What's x? It's 1.5. Now, I would not leave that to looking at my graph, although my graph is stellar and it actually crosses through 1.5. I cannot be trusted that that would happen every time. I'd probably go back to my equation and find the x-intercept using my equation. So I'm just going to do that in here. 0 equals 3 minus 2x. So 2x equals 3. So x equals 3 over 2. So we know that that is 1.5. Make sense to everybody? Because then if we do the square root of that, we know that that's 0. So I'm going to take my highlighter. And that's going to be the most important point because that's your So we need to know what the x-intercept is because that's going to be the beginning of our radical graph. It's the smallest y value that we can actually perform a square root on. So that's super duper important. Okay, Now let's graph those. So we have 0, 0. And then our first one, we have that one first. And then this one, so 1, 1. Oh, look at that. Weird. What? We have 1.5 and 0. And then we have 1 and 1. And then we have 0 and 1.7, which would be about there. And then negative 1 and 2.2. And what happens between those first 2 points? What happens between those first 2 points? The bubble. So we need a closed circle on this end, because that's where my graph starts. But I need an arrow on this end indicating that it could continue on. I just don't have the time or space for that. Okay, that bubble's really bubbly. That's probably a little too exaggerated. Your bubble shouldn't be that bubbly, but it should be a bubble nonetheless. Okay, I think that looks exactly like the first line I put on there. All right, find the domain and range of both the functions. Look at that, I actually read the question. Okay, under the f of x graph, what's my domain? On the linear function, what's my domain? Negative infinity to positive infinity, XER, anything like that will work. And my range, same thing. Now, if I'm going to do my radical function, what's my domain? Exactly. So we've got negative infinity to positive 1.5, inclusive. And if you switch the order of those, ladies and gentlemen, that's a half mark deduction. And the range, 0 inclusive to infinity. Okay, so I've crammed a lot of things in there. I'm going to add one more thing. I'm going to cram it in here on the top. You need to find the x-intercept. Now, I'm going to do this because once we move to parabolas, how many x-intercepts can I have? 2. All right. Okay. Common points. What points are invariant points between the graphs?
1.5.
So we know that when y is equal to 0 or 1, that's an invariant point. And we all remember what that means, invariant points. That means they're on the original and they don't move when we root them. They, no matter what we've done, they stay put. I feel like I'm just all over the place with my notes today. Okay, so these are just some statements that we talked about that you already know. The domain of the square root of the function consists only for the values in the domain for which y is greater than or equal to 0. We know that. We can't square root negative numbers. We know that. We're smart people. We just don't usually read it like this. The range of the root function consists of the square roots of the values in the range of the original function where f of x is defined. So all that means is you're square rooting the y's where you can. So we're just square rooting the y values. We did not do anything to the x values. Okay, pretty straightforward, right? All right. Identify and compare the domains and range for each one of these graphs. So again, because I am a visual person, I think that the easiest way for me to do it is to draw a pretty picture.
Or you said those.
Pardon? Or use Desmos. But if I were doing this on a test, I'm not going to have that as my tool, but I could totally use Desmos to start me out. This makes no sense to me. I don't know what that looks like in my head. I have no clue what that looks like. But I'm really good at parabolas. I'm really good at parabolas.
Isn't class supposed to give us trauma from the past 2 years of high school?
So what I'm going to do is I'm going to look at this, and I'm going to picture this graph. What do I know about this graph? I know it opens which way? Down. Where's my vertex? 0 and 2. So I know that I have a vertex at 0 and 2, and I know that it opens down. Everybody good with that? What are important points? X-intercepts, right? And vertex. So, and which way it opens. The reason why the x-intercepts are important is because that is, we're only going to be able to take the square root, or we're not going to be able to take the square root of these because they're negative y values, right? Everybody good with me? Maybe let's do the domain and range on this one. We'll just do the domain and range on the original graph. So what's the domain for f of x graph here, the parabola? Range? Yeah, good catch. So negative infinity to the vertex, and the vertex is included in that. Right, so those were important points. But now when we look at this graph for our square root of it, we know we have to square root the y values. We also know that we need the x-intercepts. Can you guys find the x-intercepts from this equation? Pretty straightforward. I guess we're like, maybe not. So in order to do the domain and range of the rooted function, we need to find our x-intercepts. So I'm just going to do some math on the side. So I'm just going to go back to that parabola. So I've got negative 0.5x squared plus 2
I just graphed it. It looks really weird.
So we need both the plus minus. So if I slide back over here, we know that this point is at positive 2 and 0. And we know that this point here is at negative 2 and 0. So we need both of them. We need both the positive principal root and the negative root as well. And so that helps me because my radical graph, I know that I can't do anything with this down here. What happens to my y values? We square root them, right? What's the square root of 0? 0. And this point here is going to be 2 and 0. So those aren't going to change. What's the square root of this coordinate pair? 0 root 2. So we did in the other table of values, the square root of 2, so this is going to come down a little bit. So this is going to be 0 root 2. We know that root 2 is an equivalent value of 1.7, so it's going to be obviously just a little bit lower than the 2. So really, these are the only y values on the graph I have. Because I can't square root anything down here because those are negative y values. So now with this little drawing, I can do my domain and range. What's my domain of this graph, of the pink graph? Inclusive. And the range, how low do we go? 0. And how high do we go?
1.4.
Wait, Ms. Galvin,
Yeah.
how come then on the last graph, it
Uh-huh.
went to negatives for the domain range? And for
That was on the first graph. Like that was on the linear. That was on the linear. But when we square rooted them, what happened to those negatives?
Since it goes to negative, like negative infinity on the domain and positive infinity on the range,
Yeah.
there not be a negative infinity.
On this one, no. Because where am I? Because it actually stops here. If we went negative infinity on the x, this would get us into negative y's. And I can't do anything with that. The only place I have positive y's are between -2 and +2.
Okay.
So remember when we did absolute values? Remember when we did absolute values with parabolas? We had the hump and the 2 arms. Remember that? We're going back to that, the hump and the 2 arms, okay? So just keep that in mind. All right, let's look at this next graph. So I'm going to do a sketch of this. Which way does this graph open?
Up,
Up. Where's my vertex?
up,
Are there any negative y values?
no,
So this entire graph is fair game to be rooted because all the y values are positive. This point here was 0, 5. So when I do my square root graph, where does that point move to? Yeah, so it's just going to move down to 0 root 5. Doesn't really matter about the rest of it because they're all accessible. It will change based on like the start point. Okay, so let's do the domain and range. Oh, do I need x-intercepts on this one? Are there x-intercepts?
No.
No, hence why we're not solving for them, right? So I find doing a little sketch helps me see it better. Some of you are magic minds and can see this all in your head. You do not have to draw these pictures. I'm just drawing them because 1, they help me, and 2, they make your notes a little bit more complete. We know where we're getting these values from, hopefully.
Oh, this is messes with your mind. It looks like a parabola, but it's
So this one here is domain is going to be negative infinity to positive infinity, and the range is going to be for the black graph. No, black graph. Okay, Rahat, I'm going to ask that you take out what you need from that container and stop opening and closing it. Okay? So this is for the original graph. And now we're going to go to the rooted graph. And the domain, it includes all x values. So we're going to have that negative infinity to positive infinity here. It includes all x values because all x values have positive y values. So there's no restriction on the domain. But now my range starts a little bit lower. It doesn't start at 5 because we're square rooting that. So it's going to start at root 5 and go to positive infinity. Do you guys want to try the last one on your own, or do you want me to do it? Yep, people?
When like the f of x graph has zeros, does the zeros not move when you, square root it?
Correct, because when you take the square root of 0, it's still 0, and that's those invariant points. So your x-intercepts are invariant, and where your y is equal to 1 is invariant. So when we talk about key points on the graph, like if you look at the marking guide on those old provincial exams, you'll see things like key points indicated. Key points would be those invariant points, which are your x-intercepts, those sort of things. Like those would be really important points to have on your graph. Okay, you guys try this. You guys try it on your own. Do a rough sketch. Okay, put the phone away. Do you have your domain and range done?
I got my domain for the first one, for the second, for the square root, I want you
Is that a yes or no?
It's a half.
If I can turn an on-off switch into a no. What is it?
All right.
Asking yes or no gives you a really.
I'm going to show you my pictures because you probably might have struggled a little bit with the pictures. And I'm going to show you my domain and range for the first one.
I did not get it right. I put in
to. I had a
the
feeling it was gonna be
middle.
the half.
But we know that the middle are the negative
Yeah,
values,
well,
right?
When you said we're redoing the thing.
Yeah.
I flipped it up.
You were absoluting it.
So the,
You flipped the hump.
for the root function, would it be a unison?
Yes. So now we kept the two arms and we've eliminated the hump because the arms were positive, not the hump. The hump was negative, so we know that the negative part of that graph goes away. And you'll notice that my arms don't follow like that kind of straight up smooth pattern of the parabola. It's because we're square rooting all of them, so they tend to kind of splay outward. We could do a table of values and I can show you exactly why, and I'm sure you're super pumped to figure that out, but you don't have to. This kind of messes with your mind because you have a square root in there. And you're like, oh, now I got a square root, that feels really ugly. But you don't because you're only square rooting the y values. So my x is at a root 2, but when I square root 0, it's still 0. So those x-intercepts are invariant points. They don't move. You just have to decide, can you square root the arms or can you square root the hump when you're dealing with a parabola? So for this one, so that would be the domain and range of the original graph, which I'm assuming you all got 100% correct. And if we were to do the domain and range of the root graph, the domain is going to be the in unison one. It's because we're dealing with two parts with a gap in between, kind of like your piecewise function. So we're going to look at the left arm first. How far left do we go? Negative infinity. The farthest we go is negative infinity. And then on that arm, where do we end? Negative root 2. But it's inclusive of negative root 2. And then we're going to do the in unison, so the U without the stick. And now we're going to look at that right hand arm. Where do we start? We start at positive root 2, and we go all the way to positive infinity. Now we got to do the range. Range is super easy. No in unisons, no nothing there. So 0 to positive infinity. Okay, fun times. But you need to know stuff about parabolas. So if parabolas are something you still struggle with, then this might take you doing a table of values to get your parabola on there. You might want to use Desmos or graphing calculator software or an app that will graph it for you. The trouble is I'm going to take that device away from you when you do your test. So you need to have some knowledge about parabolas. So if you're using Desmos, you need to make sure that you truly understand how we got that original graph, because I'm going to ask you to do it without technology. You got to use your brain. Okay. Okay, this is exam question, essentially. So you guys are going to feel really super comfortable with this. Super duper comfortable. Because I don't think this causes you any problems. So if I give you a graph, I give you no equation. I just give you a graph and say, graph the square root of the function. What are you doing? You're square rooting your y values. If you can do that. So locate the invariant points on the graph. So x-intercepts, that's when y equals 0. Oh, sorry, you guys can't see that. That's your x-intercepts, and where y equals 1. So I'm going to locate those on here. There's my x-intercept, and there's where y equals 1. Those are your invariant points. So I've located them, I've indicated them, I am using pink, but it's not coming out very bright. Locate other key points on the original graph where the values are greater than 1. What's the next point you would pick to graph? What's the next point you would pick to deal with? I deal with the y-intercept. How come? Because it's a perfect square. I can do that in my head, everybody. Can you take the square root of 4?
Yes.
Yes. Because this might be on a non-calculator portion, right? So I'm going to pick points that I'm comfortable with. I'm going to work smarter, not harder. And there we go. We got 3 points. That's good enough for me. So what happens between point 1 and point 2 and the invariable points? We got the bubble, right? We got the little bit of a bubble. All right, good job, everybody. We graphed it. What am I missing? Points. There we go. Now I get full marks for this. All right, let's do the next one. Super easy. Super easy. What am I going to find? My x-intercepts and where y equals 1. So I have y equals 1 here, and I have y equals 1 here. I have an x-intercept here, an x-intercept here. Where's the next point that you're going to graph? I'm gonna go back to that 4, right? Let's say I don't have a calculator with me. It's not super nice. 4's kind of right here. Would you guys agree with me? That's 4. So it's just beyond 3, like a smidge beyond 3. So I'm just gonna translate that down to there. A smidge beyond 3. And I'm going to translate that down to there. A hump between the first 2. Ooh, that wasn't a very good hump, but still a hump nonetheless. And there we go. Oh, I'm not done. What didn't I do? And ladies and gentlemen, again, pick points that make the most sense. Like, because it was a little bit beyond 3, I was going to have to estimate, so I wouldn't label that point. I'd label points that make the most sense. Yeah.
You want us to label it, the graph too?
Yeah, you probably should because we have 2 graphs. Oh. So notice I made a boo-boo there. I was going to put f of x. What's the original function? G of x. So I need to put g of x under the root sign. I have 2 graphs on the same coordinate plane. You should always label it. And that's it. Like, that's all. I've seen this as a provincial exam question, and it's a 2 marker. FYI, there's no more than 4 marks on a question. There's nothing more than that. There's a small section of multiple choice. They're at the beginning of booklet 2. I still don't have the date for you guys, but I'm going to say it's the Tuesday before our exam week, because that's usually when it's been. So that's what I have there for you. I'm going to take a moment.